Hi, in this video we'll be talking about a nice problem. So let's just get into the statement. So you're given an 2D array of dimension n cross m with some initial values in the cells. Now for each of the query, you need to find out the sum of the triangles shown in the diagram. So there will be q queries, okay, and for each of the query you are given x, y and l. So x comma y means this lowermost point of the triangle, and this will be the shape of triangle, and you are given the L, so that is the size of the sides of the triangle, right? So this is the region of which you need to find the sum of values. Okay, so whatever the values over these cells are, you need to sum them up and you need to tell the value for each of the query. So you need to do this for q of the queries, and you need to find the values modulo 10 to the power 9 plus 7. Okay, and if a triangular region say starts over here, so the next cell would be this, and the next cell goes outside, right? So if anything goes outside, you take the value of the cell to be 0, like that cell that is outside is actually having 0 value. Okay, so that you need to take care of. Okay, so if we talk about some examples, like this would be a small example, like this is the cell that is x comma y and the L length is 2, right? So if this is 4 comma 2 and the side length is 4, so this would be the triangle, and this is what you need to find the sum of. And there is this one cell that goes off the grid for this triangle, but we assume that everything outside this grid is 0, so that's not a problem. So how to process such weird queries? Like we can process rectangles and stuff, but how do we find out the sum of triangles in a 2D matrix? So for rectangles, we used rectangles from the 0 comma 0 to that point and saved all these values as prefix sums, and then used that to construct any other rectangle, right? So to conquer triangles, we need triangles. So we keep triangular prefix sums at cells. So when you have this kind of triangular shapes, what you keep is this value p for any cell. Okay, so let's suppose this cell 4 comma 3 that is over here, we store the value over here in the p array as the sum of the values in the region that is covered by this yellow, right? So everything above that in the triangular region until the last row, that's it. Like this is the same triangular region that we would have drawn, but the L value is now till the last row, like it covers everything. So this is the triangular region that we are saving in each of the cell, right? So in case this is the cell that we try to keep prefix sum of, so the prefix sum that we keep at this cell is equal to the sum of this region that is covered by the blue, that is this triangular region up to the first row. Okay, in case in this yellow where the first row's last element got outside the board, we don't really need that, so that is 0. So this is the region that it stores. So this is what we try to store in the cells. Okay, so first of all, this is the prefix array table that we will create. Now how do we create this? So this is the target kind of value, right? Like this cell should store this value. So what we can do is that we can decompose this into two values. For this cell, when you need to find this triangular region, you can break it down into this rectangle and this triangle, right? So this triangle starts over here and this rectangle starts over here. And if we try to compute the things in an order in this order, like from 0 to 5 in a row major order, so in that way, if you come to this value, you know that this value has already been computed, right? So you have this value and you know this rectangular sum. So we can use rectangular sums, and to find out rectangular sums, you can easily use prefix sums of rectangles, right? So we already know that how to find out the sum of a rectangle in any 2D array, right? So we can use that technique to build a prefix sum before even computing this one. So we keep a rectangular prefix sum beforehand to compute this value. So this is one method that you can use. Okay, the other way is you can even use triangular prefix sums alone to calculate all the values. So let's say you need to find this red region, right? So you already know this ARR of I comma j, this is just an individual cell. Then you need to find this green region and this yellow region, right? And this yellow region can be broken down into two triangles, this blue region and this red region, right? So if you subtract this red region from the blue region, you get a shape similar to the yellow region. So something similar to that we can do over here for this yellow region, that this would be this value minus this value, so that would give you this yellow region, right? So this value minus this value would give you this yellow region. Like this triangles get subtracted and you have this rectangle over here, so once you subtract you get this yellow region, right? So this yellow region, this green region is directly this cell, and this is the value. So you get ARR of I comma j, that is this value, plus this cell, that is green region, plus this value over here, that is I minus 1 comma j, that is this cell minus this cell, right? So this would be the value at this cell, right? This is the prefix sum, the sum of the values in this red range. Now once we have this prefix sum, what do we do? Like how does building this triangular prefix sum actually help us calculate anything other than that? Like how do we calculate this triangle of some side length L given to us? So what we can do is that we can take the whole prefix sum from this cell, right? So we can take all of these into consideration first. Like let's say we take all of these into our summation, but again these are the extra cells, right? These are some extra cells that we have. So what we can do is that there is a triangular region over here which we can subtract out, right? And notice that this triangular region also has the base 0, right? This triangle has a base 0, so you can subtract this cell out and you will get just this part, right? This part over here. Like if I shade that out, this would be the part, like this part would be remaining once you subtract this yellow part, right? Now if you subtract this green part as well, you're only left with this blue part, okay? If you subtract out the yellow part and the green part from the red one, you leave with the blue part. So that's what's shown in this color code, right? So how do we calculate this green part? So this is like a rectangular prefix sum, so you can keep the rectangular prefix sum and this value of the rectangular prefix sum minus this value. So in the rectangular prefix sum, this value stores the sum of this rectangle, right? So if you think about it, this value would store the sum of this rectangle, right? And then if you subtract this value out, that would subtract out something like this, subtract. So this value minus this yellow region, so that would give you the green region, right? So to find out the value for this blue triangle, what you can use is that the p of x comma y, so this was given to be x comma y, right? This is given to be x comma y and this is the length L, right? So p of x comma y will give you this red region. Now you need to subtract this yellow region and the green region, right? So if this is x comma y, you go L times to this, so this will be x minus L and this will be y minus L as well. So this is p of x minus L comma y minus L, right? So you subtract this value out, so you get this region over here, right? And then you need to subtract this rectangle. So what you can do is that you can find out this cell, this is x minus L comma y, right? And then from this prefix sum, so this R is like the rectangular prefix sum that we built, so from that you need to subtract this rectangular prefix sum, right? So for the rectangular prefix sum as well, you need to subtract this value minus this value, because this actually holds the sum of this whole region, right? And you need to subtract this region. So this is how we get the rectangular prefix sum. So in fact you need to just query out this rectangle, this green rectangle, out of the rectangle prefix sum. So you have built the rectangular prefix sum before that, so we can use that over here. And by this technique we can decompose any triangle given to us into either smaller rectangles that lead up to the first row, that is what we are saving in the prefix array, and these rectangular regions, right? Those triangles and rectangles, that's it. So we can decompose any given triangle with this, and with that we can solve the problem in order 1, right? Every query we can get in order 1, right? So to build the whole thing, to build the whole prefix part, you will need just order n into m, that is iteration on the whole array once, using this relation, that if we quickly go back, if we use this relation, this is just like a simple iteration on the whole array, right? And we can just fill in the values using this relation. So that would take you an order n into m, right? And plus for each of the query you now need only order 1, right? So you could have thought about this problem in a brute force way that would take you order n square per query, order n into m plus query, n into m times per query, and you could have saved a bit on that by keeping a row wise prefix sums, but that would have only led to q times n, right? Like the query times the number of rows or number of columns, right? Q times n. So this technique, by decomposing and keeping a prefix sums of triangles leading to the last row, you can find out the sum of any triangular region in a rectangular matrix in order 1. Okay, so that's all for this technique. Thank you and see you in the next video.